So again, if we want to know what t is, we need a logarithm. If you look up logarithm in a dictionary, you'll find that a logarithm is an exponent. So this is super important rule number one about logarithms. Logarithm and exponent are synonymous. They mean the same thing. When we write that down, it looks a little different, but bottom line, a logarithm and an exponent are exactly the same thing. So just super example, we'll test out on our calculator. If I take 10 to the second power, what do I get as an answer? 100? Yeah, so I get 100. So 2 is the exponent, is it not? Yeah, so that means 2 is also a logarithm. So I'm just going to write that down. 2 is, and often we don't write out the whole word, we just write log. So I'm just taking the definition from the dictionary where a logarithm means exponent, and I'm writing down 2 as a log. Now, in order to have an exponent, you have to have a base, true? What's the base here?
10.
Yeah, so here the base is 10. So just like a power needs to have a base, a log needs to have a base, and that base gets written as a subscript by the g. And then next to the word log, we put a parenthesis, and we put the other number. So the only number missing here is the 100. So the 100 has to go in parentheses here. So the way I read this would be 2 is log base 10 of 100 is the way I would read that. Now, often log 10 comes up all the time because our numbers are based on 10. So usually you'll see that written without the 10. So here's another way to write it. 2 equals log 100. So if there's no base written down by the log, you just say, oh, it's got to be 10. So we're going to test this out on the calculator. Your calculator should have a log button. So look up your calculator right now. Take it out. I'm going to use my Google calculator. And on my calculator, I'm just going to type, there's a log button on my calculator. And then I'm going to type 100. And notice my calculator does not put a base by the log. So what is the calculator assuming the base is? 10. 10, assuming the base is 10. And I hit enter or equals, and the calculator should say 2.
This calculator works.
All right, so we got to get used to how our calculator does logarithms. Now, I often prefer a spreadsheet to a calculator. I can do the same thing on a spreadsheet. Excel works the same way as Google Sheets, and Apple, if you're an Apple user, Numbers works the same way. To type, let's see, let's suppose I do 100 instead. So there's one formula on a spreadsheet called log, and it says, okay, what number do you want the power of, and what is the base? So I would say I need the power to get 100, and the base is 10. And so if I type that with an equal sign, it should say the power you want is 2. Because a logarithm is what? It's an exponent. It's a power. Bless you. So there's another formula the calculator has. It has a formula called log 10, which means log base 10. And so if I go into my spreadsheet and I type what is log 10 of 100, it'll return back 2. So the spreadsheet has a log, a couple of different ways to do logs. Calculator usually only has 1 or 2 ways to do a log. We're only going to worry about one way for now. Okay, so the button LOG. So we're going to try a couple more examples where we get to use that. So let's try another one. Let's take log base 10 of 1,000 equals what? I'm going to put a question mark there. So write that down like that. So first thing I want to know is what's the base here?
10.
10 is the base, right? Which thing here is the exponent? The 10, the 1,000, or the question mark? Yeah, the question mark, because a log is a power. So the power has to be question mark. And that means the 1,000 has to go on the other side. Come on, pen. There we go. So when I read something like this, I say, okay, 10 to what power is 1,000? Can anybody guess what the power is? 3, yeah. So if we go into our calculator and we type what is log of 1,000, the calculator should spit out a 3. 3 is the power we want. Okay, so we're just warming up, learning how you write these things down and typing them in. So I just type log 1,000 equals 3. So those are all, I picked these numbers because they work out nice and we can look at it and guess. We need logs for problems we can't guess at. So for example, I know that 10 to the third power is 1,000, and I know that 10 to the second power is 100. So kind of in between those, I wonder 10 to what power is equal to 700? Right? Well, it's not a whole number because it's somewhere between 2 and 3. So what I want to do is I want to turn this red statement into a log statement. So the way I do that is the first thing I do in this case is write down the power. My power is question mark. A power is always equal to a log. That's number one rule of logarithms. What's the base of the log here? What's the base of the problem above? 10. And I put my parentheses, and I put the 700 inside the parentheses. Okay. So the two things I can easily get when I look at an exponent statement, the power is the log. And then the other number has nowhere else to go but in the parentheses. So on my calculator, I would just type what is log of 700. So let's check, see what the calculator tells us. Log 700. And you want to get into the habit of closing the parentheses on the log if your calculator uses parentheses. If it doesn't use parentheses, then your calculator is dangerous. And you could be at risk of messing logs up. So if that's the case, talk to me later about it because I want to help you either get a better calculator or fix your calculator. So my calculator says the power is somewhere around 2.845-ish. That's between 2 and 3. Okay. So to double check that, so let's say I round it to 2.845. If I take 10 and raise it to the power 2.845? Yeah. I should get about what is an answer. I'm hoping 700. So I hit equals 699.8. Yeah, that's close. Since I rounded the power, I get a rounded answer, approximately right. Okay. So that's the idea of a logarithm. Now, there's some special properties of logarithms I'm going to write down, and then we'll use them in different ways. And so our goal in this section right here is to get used to how to write down logarithms, when they apply to exponents, and then we're going to use them to solve equations we couldn't solve before. So some properties of logarithms that we need to know. So the first one is kind of like they're related to exponents in a couple of different ways. So if I do something like log base 10 of 10 to some power, let's call the power x. The answer here is going to be x. And the reason is, what does a logarithm do? It tells us what power we need. So this says, let's see, where's my laser pointer? 10, come on. Oh, you guys see a laser pointer? Oh, there it is. Okay, so this 10 to what power gives me 10 to the x? Well, it's got to be x. Okay. If we think back to a previous example of that, we looked earlier at log base 10 of 1,000. And what did we believe the answer was according to the calculator? It was 3. So isn't 1,000 equal to 10 to the third power? So if I wrote log base 10 of 10 cubed, what's the answer here? No, not 1,000. 3. Yeah, so just double check. 1,000 is 10 to the third, is it not? And this statement over here says 10 to what power equals 1,000? The answer has to be 3. Another way to think about it is if you have the same base here and here, they pretty much cancel each other out. Kind of like adding and subtracting cancel and multiplying and dividing cancel, the powers cancel. So let's type that into a calculator, make sure we're not making shit up. So if I type log, without a base, what do I assume the base is? 10, right? And then I say put inside there 10 raised to the third power, the computer's going to say the answer is 3. If you have the same base for the log and the exponent, they kill each other, cancel each other out. Power is the only thing left behind. Okay? So that's going to be an important property we're going to use later. Another important property, so let's circle that. If you have a log of some number to a power, that power pops out and gets multiplied. So we'll test this out. So that's the rule. We're going to test it. Now, when we're doing math problems, the base isn't always 10. It's often something else. Like when we were playing with car depreciation, the base was 0.85. When we were playing with interest problems, the base might have been 1.05. So we got to get used to working with bases besides 10. And that's where this rule comes into play. So new page, let's test it. So if I had something like log of 0.85 to the 7th power, my rule says that I can pull the power out, that this should be equal to 7 times the log of 0.85. So what I want to do on my calculator now is I want to type my first expression in the calculator, see what I get, type the second equation and hope they match. Okay, so do these things, check. So on the calculator, log of 0.85 raised to the power 7, my calculator thinks the answer should be negative 0.494-ish. Anyone else get that? So again, I'm trying to type this right here. Log of parentheses 0.85 raised to the power 7. And my calculator thinks it's negative 0.494 about. I'm going to make a note of that. So this is about negative 0.494. So now I'm going to type this and hope I get the same result, because that proves I'm trying to justify my property is true here. So now I want 7 times the log of 0.85, close parentheses, and it looks like the same number to me. Even out to more decimal places, it should be exactly the same number. Okay. So we're going to use that property to solve stuff. So I'm going to show you how we're going to do that right now. And we'll start off with a relatively simple problem. So let's take the car depreciation problem where we were losing 15%, which means we keep 85% of the value of the car. And what I want to know is, when is the car going to be worth half of what it used to be worth? Well, half of what it used to be worth, I could write as a decimal as 0.5. So that's the question that this equation answers is, when is my car going to be worth half of what it was originally worth? So the way I'm going to solve this is, when we solved equations before, we did things like multiply on both sides or divide on both sides or add or subtract on both sides. It turns out, just like you can add, subtract, or multiply on both sides, you can apply a log on both sides. So I can take and write log on each side. And on this side, I have the log of 0.85 to the t. And on the other side, I have the log of 0.5. So all I'm doing is applying a log on both sides, just like I would multiply on both sides or divide on both sides. Now, it's not a multiplication, though. I'm not multiplying by the word log. It's more complicated than that. Now, what property do I have here I can use? Well, the property I can use is that exponents pop out. So now I can rewrite that as t times the log of 0.85. On the other side, I still have the log of 0.5 hanging out waiting to do something. Now, we have calculators, right? On the calculator, we can just plug in that and get an answer. It's some number. It's connected by multiplication. So how do we get rid of multiplication?
Divide.
We just divide by it, okay? So I'm not going to bother plugging into my calculator yet. What I'm going to do is I'm just going to divide both sides by this number, and this number has a weird name. Its name is log of 0.85. And if I divide on one side, I have to divide on the other side. Now, the log is attached to the 0.85, just like my first name, Gary, is attached to my last name, Parker, right? I need both of those for my name. So I can't get rid of the word log. I'm stuck with it until I plug it into a calculator. But I'm going to make this note. Here I have a number divided by itself, don't I? What's a number divided by itself always equal to?
1.
1. Yeah, so this gives me 1. 1 times t is t. Now on the other side, you might be tempted to cross those logs out. That's totally illegal. It's not allowed. At this point, I have to enter this into my calculator.
Because they're not the same.
Okay, so try to type that into your calculator. Let's see if we can agree on what that should be. Important thing about your calculator when you type that in is your parentheses start and end in the right spots. So try typing that in, and then I'll type it in, and let's hope we match. So let's see, I had the log of 0.5, close the log, divide, log of 0.85, close the log, and if I typed it right, my calculator says 4.265-ish, so hopefully you get the same number. If anyone has an iPhone type device and you're trying to use the Apple calculator, it sucks. Get a different calculator. So I think the answer is 4.265. Now, if this is the car depreciation problem, that means in about 4.25 years, my car will be worth half of what it used to be worth, if it's losing 15% per year. Eek. Don't buy a new car. Buy a used car. All right, so I need to double check that's true because that was some crazy weird math. I don't know that it's true. So, but I think the answer is 4.265 about. So to test that, I got to go back to my original equation. Oops. Original equation was, and a pen would help. How about that? 0.85 to the power t. I was wanting to know when was that equal to 0.5. And we believe that t should be about 265? Okay, so to test it, we just plug it in. So what is, according to our calculator, that's a decimal point, 0.85 raised to the power 4.265. It hopefully is pretty close to 1/2. So 0.85 raised to the power 4.2, oops, missed something there, 2, there we go, 65. Calculator says, yeah, that's about 1/2. That's not bad. So without logarithms, we cannot solve an equation where the power is unknown. Okay, so let's do one more example, and then I'm going to set you guys free on your tasks today. Suppose it's a slightly more complicated question, and I'm going to go for a medium complication, like 3 times 2 to the power, let's call it x this time, is equal to 7. Let's suppose that's the problem I have. And that's confusing. There's too many x's there. Let's put a little dot for multiplication. Come on. Dot, dot. There we go, dot. So 3 times 2 to the x. So I need to get the x alone, right? That's my goal here. Solve for x. Before I can get that power down, I got to get rid of the multiplication. That's got to go first. So my first step here is to divide by 3. Now on the left-hand side, I have a number divided by itself, which is 1. 1 times 2 to the x is just 2 to the x. On the other side, I have 7/3. I got a couple options on 7/3. I could leave it alone. I could change it to a mixed number, or I could plug it into my calculator. My recommendation would be leave it alone, but I'm going to try the calculator, see what happens. 7 divided by 3 is 2.33333. The problem with this number is in order for me to write it on my paper, I've got to round it because the 3's go on forever. So either you have to deal with rounding error right up front or just leave it as a fraction. What do you want to take a risk with first, rounding error or a fraction? Fraction? Yeah, that's what I would do. But if the fraction freaks you out, then write down 2 and a bunch of 3's with a decimal point. So I'm just going to leave it at 7/3. Now that I have the power alone, now I apply logarithms to this. So then I say, all right, the log parentheses of whatever's on the left, happens to be 2 to the x, has to equal the log parentheses of whatever's on the right. So basically you just rewrite what you had above with log containing stuff. Then we have a special property. What happens to the x next? It pops out. That's the magic rule. This is the most important thing about logarithms besides a log as an exponent. Back here, this rule right here, that if you have a log with a power, the power pops out as a multiple. Okay. That and the other rule I gave back here is that log and exponent mean the same thing. Those are the 2 most important things you need to know today. Okay, let's finish this. So I pop the x out. So now I have x times, that's a times, come on, oh well, log of 2 equals log of this number 7/3. Now, I can't get rid of the word log without using a calculator, but I can break that multiplication right there by doing what? Division, yeah. So what I want to do is I want to divide this side by the log of 2, and I want to divide this side by the log of 2. Can I cross out those words log? They don't cancel. You got to plug them into a calculator. Okay. So right now, what do I have going on? Well, I have a number divided by itself, which is equal to 1. 1 times x is x, so x has to be equal to whatever that is, which means it's calculator time. All right, plug that into your calculator. Let's see if we can agree on what the answer is, and then we'll try to check it. So let's see. Log of 7/3 first, divide by log of 2. Is that right?
Mm-hmm.
And you want to get used to on your calculator seeing if you can type things in one shot, because if you type a number and write down an approximation, then type another and write down an approximation, you're going to build up rounding error, which is sometimes going to be a problem. So we want to practice trying to type things like this in one shot. My calculator thinks the answer is 1.222 to 3 decimal places. So is it right? I don't know. Maybe.
Plug it in.
Plug it in. You got it. Let's check it. So I'm going to go back to my original equation, which was 3 times 2 to some power equals 7. And I think that power is about 1.222. And hopefully I get about 7 when I plug that in. So 2 times, nope, I got that backwards. It's 3 times 2 to the power 1.222. And the more decimal places you plug in, the closer you'll get to the actual answer. So I got 0.6998, which is pretty darn close to 7. So
So do
in
you
my
always
notes,
want us to round to 3 decimal places unless it's specified?
No, it kind of depends on the problem. So I got to answer a question from Kristen online. She says, do you always want to round to 3 decimal places? And the answer is no, it depends. In this case, I thought 3 was okay. If the problem doesn't say it, I might go to 4 or 5 to be safe.
Okay.
So I'm just going to say that was about 7. It checks. So the answer is X is about 1.222 because it checked out. So our goal here is, again, to get used to this idea of logarithms if you've never seen them before. If you have seen them before, you remember how to use them, maybe not. They're a little bit tricky. But again, summary, the 2 important things you need to know is that the word logarithm means the same as exponent or power.
How did I earn a credit line increase?
Oops, that's me trying to spell power. There we go. The other important thing to know is that if you have a log of something that has a power, that power pops out as a multiple. Those are the 2 most important rules of the day. And they'll get us through this lesson right here.
Equals.
All right, so those are the basics of logarithms. Your goal right now is to jump into this assignment.